So good evening, all of you. Yesterday we completed some basic concepts of chemistry, and we have one more topic, that is redox reactions. So that is redox reaction. So let us see. So let us see redox reactions. Okay. Now, if both oxidation and reduction takes place simultaneously, then it is called a redox reaction. Then it is called a redox reaction. Now let us consider Zn Cu plus 2 gives rise to Zn plus 2 plus Cu. Now here you can see zinc is converted into Zn plus 2 and copper is converted into Cu plus 2 to Cu. So what is the oxidation state of zinc here? Anything which is in elemental form, it is 0. Here copper is also 0. Now zinc changed its oxidation state from 0 to plus 2. That means increase in oxidation state. Increase in oxidation state is called oxidation. Whereas copper oxidation state plus 2 to 0, that is decrease. Decrease in oxidation state is called reduction. So the given reaction is a redox reaction. It comes under what type of reaction? Redox reaction. Understood? So this is about introduction of this chapter, redox reactions. Okay. Now here, questions will be based on balancing redox reactions. Okay, balancing redox reactions or finding oxidation states. Okay, in that first one, let us solve some questions based on determining oxidation states. Determining oxidation state. So how we can determine oxidation states? Let us start with some simple molecules. H2SO4. So what is oxidation state of sulfur? What is oxidation state of sulfur? Let us see. We don't know what is that oxidation state of sulfur. Let us consider this as X. Plus how many hydrogens? 2 hydrogens. Plus 4 oxygens. There is no charge on the molecule. It should be equal to 0. What is oxidation state of hydrogen? Plus 1. Plus X. Plus 4 into oxygen oxidation state. Minus G. Minus 2. Then 2 plus x minus 8 equal to 0, x minus 6 equal to 0, x equal to plus 6. What is the oxidation state of sulfur in that compound? Plus 6. Okay. Next. H2 SO5. So what is sulfur oxidation state here? OH, O, OH. So total, how many oxygens are there? 5. And how many hydrogens? 2. But out of 5 oxygens, here you can see these 2 oxygens are present in peroxy linkase. So in peroxy linkase, oxidation state of oxygen is -1. Remaining all other cases, it will be -2 only. So let us consider sulfur oxidation state X. We don't know. Now out of 5 oxygens, 2 oxygens are in peroxy linkase. In peroxy linkase, what is oxidation state? -1. Plus remaining 3 oxygens, they are in -2 oxidation state, 0. Plus how many hydrogens are there? 1. So each hydrogen is oxidation state +1. So 2 plus x minus 2 minus 6 equal to 0. -2 plus 2 gets cancelled. X equal to plus 6. So this is the oxidation state of sulfur in H2SO5. Then CrO5. It is having a special structure, chromium. So this is what we call butterfly structure. Now in this you can see clearly here, these 2 oxygens are in peroxy. These 2 oxygens are also in peroxy linkase. Out of 5, 4 are in peroxy linkase. Chromium we don't know yet. Out of 5, 4 are in peroxy linkase. So -1. Plus 1 oxygen is in -2 oxidation state, 0. So X equal to X equal to +6. So here it is +6 oxidation state. Okay. Next. H3PO4. What is its structure? P double bond O, OH, OH, OH. So all 4 oxygens are present in -2 oxidation state. So phosphorus as usual X, 4 oxygens -2 plus 2 hydrogens plus 3 hydrogens is equal to 0. 3 plus x minus 6 equal to 0. X minus 3 is equal to 0. X equal to +3. So here it is +3. If you consider H3PO3, so calculate its oxidation state. How? You don't know phosphorus. X plus 3 into -2, 3 into +1 is equal to 0. Sorry, here it is 4 into -2, -8, isn't it? This is -8. So X minus 5. and x equal to plus 5. What is x there? Plus 5. Here, 3 plus x minus 6 equal to 0. 3 plus x minus 6 equal to 0. X minus 3 is equal to 0. X equal to plus 3. So this is in H3PO3. Done. Okay. Next part will be balancing redox reactions. Okay. Now this part I'll include in the numerical part. Anyhow, you have to solve questions. You'll include in that. So let us move to numerical part now. Now let us see questions. For the redox reaction, this is given redox reaction. MnO4 minus plus C2O4 minus 2 gives rise to Mn plus 2 plus CO2. Okay. This is in acidic medium. So H plus indicates balancing redox reaction in acidic medium. Then how? This we are doing in ion electron method. So balancing redox reactions in acid medium. Here manganese is in +7 oxidation state, here +2. There is decrease in oxidation state. So that is what we call a reduction. Next. Yeah. 4 into minus 2 is equal to -2. 2x minus 8 equal to -2. 2x equal to +6. X equal to +3. Here carbon oxidation state is +3. Here carbon X plus, 2 into minus 2 is equal to 0. X is equal to plus 4. So this is plus 4. So plus 3 to plus 4. What is it here? Plus 3 to plus 4. That is increase in oxidation state. That is oxidation. Right? Now, divide that equation into two half reactions. How? Let us consider oxidation half reaction. Okay. This is oxidation half reaction. It's reduction half reaction. What is oxidation there? C2O4 minus 2 gives rise to CO2. Reduction. MnO4 minus gives rise to Mn plus 2. Step 1. Balance atoms other than oxygen and hydrogen. Now we consider this oxidation half reaction. Which atoms are present other than oxygen and hydrogen? Carbon. Now, here how many carbons are there? 2. Here how many are there? 1. How to balance? C2O4 minus 2 gives rise to 2CO2. Now both sides we are having 2 carbons only, isn't it? Here only 1 manganese, here also only 1 manganese. No need to balance because both sides we are having same number. That is balancing atoms other than oxygen and hydrogen. Then step 2. Balance oxygen atoms. By adding H2O molecules. What is it? By adding H2O molecules. How? Now balance. Here how many oxygen atoms are there? Here 4. Here also 2 into 2, 4. So no need to balance. Then write as it is. C2O4 minus 2 gives rise to. Here 4. It's this side zeros. That means we have to add 4 water molecules. How many oxygen is deficient here? 4. So we have to add 4 water molecules. Next step. Step 3. Balance hydrogen atoms by adding H plus ions. Now here, any hydrogen atoms are there? No hydrogen, no need to balance. So as it is, you write. Here, 4 into 2. Can you see? 4 into 2, total 8 hydrogens are there. Here, 8 hydrogens. But here, no hydrogens. So how many H plus ions should be added? 8 H plus ions should be added here. Done. Next step. This is crucial step. Balance charges by adding electrons. Now here our task is to balance charges. Okay. Write down charge here. Here in this case, -2. Here it is 0. Here it is -1. 8 into +1 +8. Here it is +2. So here it is total charge -2. Here -2 + 8 is equal to. Here you consider arrow mark as is equal to. You bring it here, -3 + 8. Total charge will be +5. Now, how you can balance electrons? Now here it is -2. Then add electrons. If negative charge is found, and add electrons on the opposite side. That means how many electrons? 2 electrons. If it is positive charge, then add electrons on the same side. Here only add electrons. Now we balance the charges by adding electrons. Let us move to last step. Step 5. Equal the number of electrons. How? Here 2 electrons are here. Here 5 electrons. So multiply this equation with 2. Here multiply with 5. Then both sides becomes the same number of electrons. And multiply. Five into 2, 10. Here it is multiplied with 2. 2 MnO4 minus plus 2 into 8. 16H plus 10 electrons gives rise to 10 electrons. 10 electrons gets cancelled. Then anything else? Then write total equation now. 5 C2O4 minus 2 plus 2 MnO4 minus plus 16H plus. gives rise to 10 CO2. We are just adding both reactions. Plus 2, Mn plus 2, plus 8, H2O. Right? Now, whether the reaction balance is correct or not, how to check? Cross-check charges again. Cross-check charges again. How? 5 into minus 2, minus 10, 2 into minus 1, minus 1, 16 into plus 1, plus 60 is equal to, here 10 CO2 0, 2 into plus 2, plus 4. Minus 10 minus 2, minus 12 plus 16, here it is plus 4, minus 12 plus 16, plus 4 is equal to plus 4. So on both sides we are having same charges. So we can conclude that the reaction balance is there. The reaction is perfectly balanced. Okay. This is how you should balance equations. Shall we solve one more question? Write down. MnO4 minus Fe plus 2 gives rise to Mn plus 2 plus Fe plus 3. Balance this redox reaction in acidic medium. So as usual, first calculate oxidation states. Here manganese plus 7. Here it is already given a plus 2. It is plus 2 plus 3. Plus 7 to plus 2. Decrease in oxidation state. So this is a reduction. Plus 2 to plus 3. Increase in oxidation state. Oxidation. Right? Now separate them. Oxidation half reaction. Reduction half reaction. Now, what is oxidation half reaction? Fe plus 2 gives rise to Fe plus 3. Reduction half reaction. MnO4 minus gives rise to Mn plus 2. What is step 1? Balance atoms other than oxygen and hydrogen. Other than oxygen and hydrogen, what are the atoms present there? Here one iron, here also one iron. No need to balance, right? As it is. Here also one manganese, one manganese. No need to balance. Done. Step 2. Balance. Sorry. Okay. Balance. Next step. Oxygen atoms. By adding H2O molecule. Here no oxygen, right? As it is. 4 oxygen, so here no oxygen atom. So MnO4 minus is raised to Mn plus 2. How many oxygens? 4. So I add 4 water molecules. Done. Step 3. Balance hydrogen atoms by adding H plus. No hydrogens, no need to balance. Next. Okay. Here 4 into 2, 8 hydrogen. So I add 8 H plus here. Now we are getting N14 minus plus 8 H plus is raised to Mn plus 2 plus 4 H2O. Step 4. Balance the charges. By adding electrons. Once again, I'm taking those equations. Now let us write charges. Here plus 2, here plus 3, here minus 1, plus 8, plus 2, 0. Consider arrow markers 0. Plus 2 in my plus 3, minus 1. Minus 2, minus 1. So here plus 5. As I said, if you get a negative charge, no, here we will get plus, right? Plus 3 minus 2 plus 1. In both the cases, you are getting positive charge. Add electrons on the same side. Here, now last step. Equal the number of electrons. Equal number of electrons. Here 1 electron, 5 electrons. So multiply with 5 here. Okay. Second equation, no need to multiply. Add both half reactions. 5 electrons gets cancelled. Then there is nothing to cancel. Now write final equation. Just add. Now to calculate whether our balancing this redox reaction is correct or wrong, cross check it by considering charges again. It's -1, +10, 8 into +1. Sorry. 5 into +3, it is 15, right? This is 15. Then balance. +2 +15 +17 on RHS +17. LHS -1 +10. 9. 9 + 8, 17. So both sides we are having +17. So this is correct balanced equation. Done. Next. And how to balance redox reactions in basic medium. How to balance redox reactions in basic medium. That also we'll see. Keep reading. Next part. Balancing redox reactions in basic medium. Okay, let us consider one example for this also. This is example Cl2 plus IO3 minus gives rise to IO4 minus plus Cl minus. How to balance this redox reaction in basic medium? This is how they will represent. So only one step changes. Here it is zero oxidation state. Here chlorine is -1. 0 to -1. Decrease in oxidation state, that is reduction. Obviously, this will be oxidation. Then segregate. Oxidation, half reaction. Reduction, half reaction. What is oxidation, half reaction? Write down. IO3 minus gives rise to IO4. Reduction. Cl2 gives rise to Cl minus. Now here, step 1, as usual, balance the atoms other than oxygen and hydrogen. Other than oxygen and hydrogen, both are same in this case. Only one iodide ion, only one iodine. So same. Here 2 chlorines, here 1. Multiply with 2. Then get even. Step 2. Balance oxygen atoms by adding water. Here 3 oxygens, here 4 oxygens. How many less? LHS 1 oxygen is less. So IO3 minus H2O gives rise to IO4 minus. Here no oxygen atoms, so no need to balance. Next. Step 3. Balance hydrogen atom. This is only the difference. This is the only difference by adding H2O and add equal number of OH minus on opposite side. On opposite side. Now this you should understand very clearly. Balance hydrogen atom. There are how many hydrogen atoms are there too? Opposite side you have to add the same number of water molecules. IO3 minus plus H2O gives rise to IO4 minus. How many hydrogens deficit? 2. 2 H2O. Same number of OH minus you have to add here. 2 OH minus opposite side. Okay. Next here. No questions, questioning of hydrogen or whatever it may be. So Cl2 gives rise to 2Cl minus. That's it. Okay. Then balance charges. by adding electrons. Once again, I'm writing those two equations. So let us write down those equations once again. IO3 minus plus H2O plus IO4 minus plus 2H2O. Here, Cl2 gives rise to right charges. This is -1, 0, -2, -1, 0. -1, -1. So total charge will be -2. Here it is 0, -2. Total charge will be -2. Then add electrons if you get minus charge on the opposite side. Here, 2 electrons. Here, Cl2 plus. Now in both the cases, you are getting the same number of electrons, isn't it? Then add both half reactions. I'm considering here. Cl2 plus 2 electrons gives rise to gets cancelled. And finally, what is that reaction remaining? 2H2O. This H2O gets cancelled. So nothing more than that. Then write down all the equation. IO3 minus plus 2OH minus plus Cl2 gives rise to IO4 minus plus 2Cl minus H2O. -1, -2, -1, -2. So both sides we are having same charge. Both sides we are having the same charge. So that is about balancing redox reaction in basic medium. Done. Then let us solve some other questions also. Okay. Write down question now. Which of the following is question? Which of the following is a disproportionation reaction? Disproportionation reaction. Options given are Cu2O plus 2H plus gives rise to Cu plus 2 plus H2O. Second option, 2Cr O4 minus 2 plus Cr2O7 minus 2 plus H2O. CaCO3 plus 2H plus plus Ca plus 2 plus H2O plus CO2. Last option, Cr2O7 minus 2 plus 2OH minus ions gives rise to 2CrO4 minus 2 plus H2O. Among these reactions, which one is a disproportionation reaction? That we need to find out. First, you should know what is disproportionation reaction. if same element undergoes both oxidation as well as reduction, then the reaction is said to be disproportionation reaction. Okay. Then let us check options here. Here in this Cu2O, copper, 2x, oxygen minus 2 is equal to 0, implies 2x equal to plus 2, x is equal to plus 1. So here copper is in plus 1 oxidation state. Then copper here, plus 1, 2, here this copper is 0. Plus 1 to 0 means decrease in oxidation state, that is reduction. Whereas plus 1, 2, here plus 2, increase in oxidation state, oxidation. That means copper undergoes both oxidation as well as reduction. So that is what we call disproportionation reaction. So first option itself for disproportionation reaction. Next, move to next question. Yeah. Next question. The reaction, this is a given reaction to Na2S2O3 plus I2 gives rise to Na2S4O6 plus 2NaI. Here, the oxidation state of sulfur is, option given is increased, next decreased, next remains the same, and the next none. So whether it is increased or decreased or remains same, let us find out. So let me write that equation once again. Na2S2O3 plus I2 gives rise to Na2S4O6. Now what is oxidation state of sulfur in both the cases? Find out. First case, Na2, that means 2 into sodium oxidation place, 2 into sulfur, we don't know, that is X, 3 into oxygen. So plus 1, sodium oxidation state is plus 1. Sulfur, we don't know X. Is 3 into minus 2 should be equal to 0 because no charge on that molecule. Then 2 plus 2x minus 6 equal to 0. 2x equal to plus 4, x equal to plus 2. So here sulfur oxidation state is plus 2. Now here 2 sodium, 4 sulfur, 6 oxygen is equal to, it is also neutral, so 0. Sodium plus 1, sulfur x, 6 into minus 2 equal to 0. 2 plus 4x minus 12 equal to 0, or 4x equal to plus 10, implies x equal to 10 by 4. 10 by 4 means 2.5. So here sulfur oxidation state is 2.5. Now what is the change? Okay, here 2.5. Plus 2 to 2.5. That means is it increased or decreased? So plus 2 to 2.5 means increased. So oxidation state is increased. Done. Next question. So redox reactions, completely numerical parts based on balancing reactions and oxidation states. Okay, we'll move to next question. In which of the following compounds the oxidation state of iodine atom is highest? Options given are Ki3, KiO4, KiO3, IF6. Okay. Here what we have to do, we have to find out oxidation states of iodine in all given compounds, isn't it? In house. As usual, proceed with one by one. Proceed with one by one. First one. Ki3. Potassium plus 1 plus 3 iodine. We don't know x equal to 0. That means 3x equal to minus 1, x equal to minus 1 by 3. So here, in first case, it is minus 1 by 3. Next case, KiO4, potassium plus 1, iodine, we don't know x, oxygen 4 into minus 2 should be equal to 0. Here also 1 plus x minus 8 equal to 0, x equal to plus 7. So here oxidation state of iodine is plus 7. Next, KiO3, potassium plus 1, iodine x, 3 into oxygen minus 2, 0. So 1 plus x minus 6 equal to 0, x equal to plus 5. Last one, IF6, iodine. Have to find out fluorine, 6 into minus 1 should be equal to 0, x minus 6 equal to 0, x equal to plus 6. So which is having highest oxidation state among all these compounds? What is highest oxidation state value? Plus 7. What is it? Yeah, plus 7. Which compound? KiO4. So this will be your answer. Okay, shall we proceed for next question? Okay, next question. the compound in which oxidation state of a metal is zero. Options given are first option Fe2CO9, second option nickel CO4, third option Fe3CO9, last option all the above. See, in all these compounds you can see there carbonyl group. So there is one generalization that in metal carbonyl compounds, what is the generalization? In metal carbonyl compounds, oxidation state of central metal atom is always zero. So in any metal carbonyl atom compounds, a oxidation state of central metal atom is always zero. So what is central metal atom in all these cases? Iron. Here it is nickel, here it is iron. So all are combining with carbonyl group. So metal carbonyl compounds. It is carbonyl. So in all these cases, central atom oxidation state is zero. So what will be your answer? All. Next, simple question. The oxidation number of chlorine in NaClO4. Now let us write down NaClO4. Sodium +1, chlorine we have to find out, let us suppose X. 4 into oxygen, each oxygen is -2. There is no charge on that molecule, so charge should be equal to 0. Then 1 plus X minus 8 equal to 0, X equal to +7. So what is the oxidation state of chlorine? +7. Next, move to one more question. When K2Cr2O7 is converted into K2Cr4, then the change in oxidation number of chromium is. Options given are 0, 3, 4, 6. Okay, now write that conversion. K2Cr2O7 is converted into K2Cr4. Then find out our chromium oxidation state. Here, 2 potassiums, 2 chromium atoms, 7 oxygen atoms. Charge should be equal to 0 because it is neutral. Now 2 into potassium plus 1, 2 into chromium, we don't know X. Oxygen minus 2 should be equal to 0. So 2 plus 2x minus 14 is equal to 0. 2x equal to plus 12, x equal to plus 6. So here in this case, chromium oxidation state is plus 6. Here, in this case, 2 potassium ion atoms, 1 chromium, and 4 oxygen should be equal to 0. Again, charge is equal to 0. So 2 into plus 1 plus chromium, we don't know x. This is x plus 4 into minus 2 is equal to 0. 2 plus x minus 8 equal to 0. X equal to plus 6. So in this case also, oxidation state of chromium is plus 6. And what is the change? Plus 6 to, what is the change? Plus 6 to plus 6. What does that mean? There is no change in oxidation state. So the change in oxidation number is 0. The change in oxidation number is 0. Okay. So then we'll move to one more question. Okay. Next question. Oxidation number of iron in FeCN6 minus 3. So one compound, next compound. FeCN6 minus 4. Next compound. FeSCN, sorry, thiocyanide. Plus 2. Last one. FeH2O 6 plus 3. Options given plus 3, plus 2, plus 3, plus 3, plus 3, plus 3, plus 3, plus 3. Plus 3, plus 2, plus 2, plus 2. Fourth option. Plus 2, plus 2, plus 2, plus 2. So let us see one by one. First compound. What is first compound? FeCN6 minus 3. Okay. Now cyanide. Cyanide is 6 into minus 1, minus 6. Total charge should be minus 3. Cyanide is minus 3. Then what should be the charge present on iron? It should be plus 3. Then plus 3 minus 6. Total charge will become minus 3. So here iron oxidation state is plus 3. Next compound. FeCN6 minus 4. It should be minus 4. Here it is minus 6. And if you want to get minus 4, this should be plus 2. Next one. FeSCN. Here it is plus 2. Thiocyanide minus 1. It is minus 1 and total charge would be plus 2. Then here it should be plus 3. Last compound, FeH2O 6 times. +3. Water is neutral, so charge will be 0. Total charge will be +3, means here it should be +3. So total, how many different? Here it is +3, +3. Sorry, this is second, right? +3, +2, +3, +3. +3, +2, +3, +3. That is present in first option. So this is correct. Next. Next question. In the reaction is one more different model. In the reaction, C2O4 minus 2 plus MnO4 minus plus H plus gives rise to Mn plus 2 plus CO2. The reductant is, reductant means reducing agent. Okay. Now, here already we calculated carbon oxidation state in C2O4 minus 2. What is that? +3. Here it is +4. Here it is +7. So +3 to +4. What happened? Oxidation. What happened? Oxidation. So C2O4 is oxidized to CO2. It is oxidized to CO2. What does that mean? It is oxidized to CO2. C2O4 minus 2 is oxidized. It's +3 to +4, right? CO2. If this is oxidized, this is oxidation product. This is oxidation product. And C2O4, what happened to C2O4? This act as reducing agent. So it says reducing agent. The one which is oxidized, the one that means here oxalate. This is oxidized means that acts as reducing agent. Okay. So one more question. Same model. Same model question. Identify oxidizing and reducing agent in, this is the given equation. PBS plus 4 H2O2 gives rise to PbSO4 plus 4 H2O. Now here, let us consider. You consider sulfur. Sulfur is -2 here. In this case, lead +2, X -8 equal to 0, X equal to +6. Here it is +6. So sulfur -2 to sulfur +6. -2 to +6. What does that mean? Increase in oxidation state. That is increase in oxidation state. That is what we call oxidation. That means sulfur is oxidized. sulfur is oxidized. Then if it is oxidized means then this species, that means sulfide ion, this acts as reducing agent. This acts as reducing agent. Then H2O2. In H2O2 oxygen oxidation state, H2O2 is converted into H2O. It's -1 peroxide, -1. Here it is -2. -1 to -2. What does that mean? Oxidation state is decrease. That means this is a reduction. That means H2O2 undergoes reduction. That means if it is undergoing a reduction reaction, then it becomes oxidizing agent. The one which is participating in reduction, that becomes oxidizing agent. The one which is reduced, the one which is oxidized, then itself becomes a reducing agent. Itself becomes reducing agent. This is one more model, identifying oxidizing and reducing agents. Then another model in this chapter is based on what is it? Based on oxidation numbers. Based on oxidation numbers. So this is all about redox reactions, right? So still we need to discuss inorganic chemistry and organic chemistry from first PU syllabus. That also will finish in day-by-day discussion. But meanwhile, you have to practice all these models as many as possible. Understood? So that's it for this session. We'll meet you tomorrow once again, and we'll start most probably organic chemistry. After completing organic chemistry, we'll move to inorganic chemistry. Right? So tomorrow we'll meet with organic chemistry. So have a nice day then. Good night, all of you.